Now I would like to discuss about the instruction formats in computer organization. So we already know that an instruction simply an instruction is a set of binary bits, that is a combination of ones and zeros, to represent specific action or function or work done by the system or computer, right? These instructions are 16 bits length for the basic computer. We already represent the instruction format, that is, this instruction has totally consisting of 16 bits, 0 to 15 bits, and this format is divided into the three parts up to 12 bits, that means 0 to 11. This consisting of total 12 bits. This represent the address of the memory location, that is 12 bits. After that one, the remaining 3 bits, that means 12, 13, 14. This is represent the opcode, right? These are the 3 bits. Opcode means operation code, the full form. It represents what kind of the operation or action done by the system. The final one bit is represented by I, that is known as the mode bit, right? The mode bit represent whether this address is the direct address or indirect address of the memory. So, to know about the difference between direct and indirect addresses, please refer our previous videos. Okay, these instructions, now this instruction format is classified or divided into the three types, that is, so the same format, that means to fetch the data or instructions from the memory. So this is the 16 bits, again 0 to 15 up to 11 bits is address, that means total 12 bits, and remaining 3 bits up to 14, 12, 13, 14 opcode, and this is the mode bit. This format of instruction is known as the memory reference instruction. Memory reference instruction, simply MR instruction. So these instructions are used to fetch the data or instructions from the memory. But we know that sometimes the data or instructions stored within the registers. So to fetch the either data or instructions for the processing from the registers, the instruction format is like that up to 11th bit, that means total 12 bits. This is register address, register address, not the memory address. And these 3 bits are, right, the 3 bits are the represent the, these 3 bits are represent the register, and the mode bit is always 0. Sorry, this this is not the register address, register operand, register operation, what kind of the operation is performed, right? This is the, these 3 bits 12, 13, 14, these 3 bits are 111, that is the register reference instruction. The final instruction is, suppose sometimes we fetch the data and instructions directly from the input device. Here, this is the IO operation up to 11th bit, that means 12 bit IO input output operation, what kind of the operation to be performed, and the remaining including mode bit and the remaining 3 bits, that means opcode part and mode bit part are all are ones. This is known as the input IO reference instructions. This is known as the register reference instruction, simply RR instruction. So please observe carefully. For memory reference instructions, first 12 bits are the address of the memory location. The remaining 3 bits is the operation, what kind of the operation is performed. For register reference instructions, first 12 bits are the register operation, what kind of the operation is performed, and opcode part is 111, it represents the registers, and mode bit is 0. For input output instructions, the first 12 bits represent input output operations, the remaining 4 bits including mode bit is all ones. So hence we are going to be consider the operations, that means performed by the memory reference instruction. Suppose the opcode value is 000, for example this is addition, and 001 this is subtraction, and 010 this is maybe the multiplication, up to the opcode values goes to the 110. Suppose the opcode value is 111, here we observe that the opcode value is 111. This is known as the register reference instruction, RR instructions. Suppose the mode bit is also be 1, all ones, opcode and mode bit value is 1. This is known as the IO instruction. So what are the basic instructions are required for the basic computer? What are the instructions required for the basic instructions? So I divide into the three parts: memory reference instruction, the second one register reference instruction, the third one IO reference instruction. So what are the memory reference instructions? This is a very important. For the basic computer we need at least 25 instructions that should be performed, right? These are the 7 memory instructions, please observe carefully. And the end operation, that is get the data from the memory and perform end operation within the accumulator, right? Data from memory M of AR, that means the data within the memory address getting end with the content of the accumulator AC. Add means memory of AR fetch the data from memory and perform with the content of the accumulator actually, right? And add. Next one, load means we are going to be load the data into the accumulator. AC is loaded with M of AR, that means the data within the memory location in a particular address loaded to the accumulator. Store, that means we are going to be store the content of the accumulator in a particular memory location. That means the content of the accumulator transfer to the memory location. The next one is BUN, branch unconditionally, right? Branch unconditionally, that means transfer the control to unconditionally. BSA, branch and save return address. Before go transfer the condition, save the return address. Remember this one carefully. I will explain this importance later. Branch and save return address. ISZ increment and skip if 0. That is increment and skip if content of the accumulator is increment and skip if content of accumulator is 0, skip if 0, the result is. Please remember carefully these 7 instructions, memory reference instructions, and add, load, store, bun, bsa and isz. These are the 7 instructions. The next one are the register reference instructions. There are 12 register reference instructions. The first one is CLA, clear the accumulator. The second one is CLE, clear the overflow flag. The third one is the CMA, complement accumulator. The next one is the CME, complement the overflow flag. The next one is the CIR, circular shift right. The next one is the CIL, circular shift left. The next one is the INC, increment. The next one is the SPA, skip on positive. The next one is the SNA, skip on negative. The next one is the SZA, skip if 0. The next one is the SZE, skip if overflow flag, extra flag is 0. And finally, the last one, 12th one is the HLT, halt, stop the processing. I will explain each and every one in another video. CLA, CLE, CMA, CME, CIR, CIL, INC, SZ, SPA, SNA, SZA, SZE, and HLT. These 12 are the register reference instructions. That means here the mode bit equal to 0, opcode part is 1. This is these operation part in the this place. The so 12 plus 7, the total 19 instructions. The remaining 6 input output instructions, that means IO reference instructions, are 6. That is INP, that means get the input, and OUT, send the output. The third one is SKI, skip on input. The fourth one is SKO, skip on output. The fifth one is ION, interrupt on. The sixth one is IOF, interrupt off. Please remember carefully: input, output, skip on input, SKI, SKO, ION, and IOF, interrupt on and interrupt off. So the total 25 instructions are required to perform any operation by the basic computer. Dear friends, remember carefully, these 25 instructions are very important. 7 memory reference instructions and add, load, store, bun, bsa, isz, and 12 register reference instructions CLA, CLE, CMA, CME, CIR, CIL, INC, SPA, SNA, SZA, SZE, and HLT. The 6 input output instructions are INP, OUT, SKI, SKO, ION, and IOF. Please remember carefully these. I will explain how these instructions are executed in our next video. Thank you.